me see. I have a copy of quiz 1. There it is. The one that's got the mixed numbers dividing?
Yeah.
Okay. Let's see. Yeah, let's see if that works out like I hope it will. Alright, so this kind of problem, that looks really, really, really just yummy. So, a side example, if it was just this, if it was just like this would be so freaking awesome, Jeff. Why didn't you make it like this? Because I didn't want to. That should be easy, period. I should be free to say that word. I know it's a 4-letter word, but it's a good 4-letter word, easy. Why is that easy? What do you do to do this? Multiply by reciprocal, right? So do 4 ninths times. And then what could you do that's really nice? Simplify, yeah. Yeah, 9 goes into 27. 4 goes into 8. So you get 3/2. That has to be easy. That tells you what to do here. Why does that not look like this? Why does that not look like this? Can you make them look like that? If you can make them look like that, then it's just as easy. All right, so what do I do to make that look like that? 5 times 7. 35 plus 1. 36 fifths divided by. Alright, so I did this to point out something. Here's where people get too excited about the way it looks at the moment. See how 5 goes into 15 and 4, yeah, except I don't have it where I need it to be, right? So what do I have to do before I start doing that? I have to, how do you divide fractions? You multiply by the reciprocal. Now does anything cancel? Aw, too bad. And they just multiply across. You cancel if you can, because that's pre-reducing. That's awesome. But you have to do what it wants you to do. You got to multiply. Nothing reduces. Oh shit! You just got to multiply. Right? 4 times 36 is 5 times 15, 75. And you know that won't reduce because this didn't reduce. No parts of it go into any other parts of it, so you can just stop. Is that cool? You guys are looking for pained expressions, but then you went, yeah, it's fine. Okay. You're like, even if I understand it, Jeff, it's still math. It still hurts me somewhere. Like, all right, shit. Yes.
I need to ask you something.
Yes.
Are we not close for me? It's been like 3 months. Are you using the same methods that this book used?
Not always.
So you use the methods in the book?
You'll be fine. Total. If in class, I've shown you a few problems with a few different ways to do things. Mm-hmm. If you have a way that you like doing things, you can bring it up in class, or if it's in the book, it's completely valid. I would tell you if there's something the book did that I didn't want you to do, and that would be a very strange day, because the book method should be a valid method. So sometimes I'll show you their method and another method that I think might work better for some people. But it depends on who you are. It's like, do you like corn or not? I don't really. Right? But then somebody else is like, are you insane? Come on, you can have all my corn. Right? You with me? So some people are like, why do you like doing it that way? That's dumb. I like it this way. And, well, it's freaking corn. Right? What you like is up to who you are. Corn.
Okay.
Yeah. They thought I said, do you like it?
You're good, you're good.
That's funny. You guys are all like, all right, I thought this guy was all right. And now he's talking about, all right, that was funny. Cool. And not K-O-R-N either. I don't know if you guys know. No fans of corn? No? Okay. Okay. Let's all get past that. That was a weird moment. But yeah, I mean, is there something specific you're looking at? Is there a different?
Only because, like, on the square rooting, I missed that day.
Oh.
I didn't get it. But then I was talking to my daughter over the weekend, and I was kind of, asking her, and she was like, I don't know how you all learned it, but I didn't learn it like that. I was like, okay.
There were two methods I showed for the square roots. No. If you got a square root that you can do, like some of these you just gotta know. You shouldn't have to do any real work. What's the square root of 81? You should know that. Because why? 9 times 9 is 81. It takes 2 9s to make 81. And this is square root, so it's looking for what it takes 2 of. Now watch this. You ready? Here's a mistake that a few people made. Not a lot, thankfully. But I really want to nip this in the bud. The answer is what again? So what would you tell this person that wrote that? And then they keep going. I'm like, all right, it goes 3. Oh, holy crap. Wait a minute. What would you tell them? What they do wrong? How could you tell them very quickly what they did wrong? What did they do wrong? Yeah, what shouldn't be here? There, that's the quick way to say it. That square root symbol shouldn't be there. Now, how to follow up with that is maybe a teacher's job. And the example I gave on the few people, I'm not naming names, but the example I gave is 6 divided by 3 equal 2 over 3? Is that true? No, 6 divided by 3 is 2. Well, where'd the over 3 go? Well, it did its job. It's not there anymore. 3 went into 6 twice. Square root of 81 is 9. The square root symbol is gone because it did its job. Why would it still be there? It'd be like, never stop cutting it in half. Chop, chop, chop. Holy shit, no. Cut it in half once. That's all it asked for, right? Does that make sense? Yes? Yes. So that's...
Again, for me, because it's been so long.
Yes.
The 3 over 64 and the 5 over whatever it is and all of that.
Oh, the cube root of 64.
Yeah.
Okay, okay. Now watch this. Now remind me again, Sharon, why was the answer here 9? And this is a square root, so it's looking for what it takes 2 of. So cube root is looking for what it takes 3 of. So one way to do this is to try to break this up. 64 is 4 times 16, and what's 16? 4 times 4. So what does it take 3 of to be 64? Yeah, so the answer is 4. Say again? Sorry?
The 5.
What about the 5?
It was one in the book. Oh, that I did my practice sheet before 5 over something.
Oh, like a 5th root.
5th root.
Alright. So what about the 5th root of 32? Well, you start to break this up. So one method for any root really is just to start breaking the inside up. Why does that make sense? Because it's asking me, what does it take so many of to make this? Well, let me see what goes into making that number, and then I can answer the question, right? So how would I break 32 up? Start breaking it up for me.
16 first, 2 16s.
Good, 2 16s. 2 8s. Careful. Okay, 2 times 4. 2 times 2, I like it. So what does it take 5 up to make 32?
5.
So the answer is 2. The answer is the thing it takes this many of to multiply to be this. That's all that means. That's what that symbol means.
Yeah.
I know. Yeah, it's been a while, which is beautiful. Some of you guys are hesitant to ask questions because everyone around you is like, I get that. And no, they don't. People do this. I'll never understand. Let me fake it to the teacher now, and then I'll get an F on the test later. What the hell sense does that make? So if you see a lot of people doing this, at least 80% of them don't mean that.
Well, I mean, if they was in school in the last 5, 10 years, they probably know it. But one of the brothers did not.
That's not necessarily true. So what I'm trying to say is don't feel hesitant to ask anything in class. And if I hear somebody say anything about a question somebody asks, that's not good. I'll take you outside sometimes. Leave them alone. If you understand the question, you're like, that's a silly question. Well, keep it to yourself. Sit there and stare at your desk, imagine something, draw a dragon, whatever. Whatever gets you through. Don't be saying nothing bad about somebody else's question. That's stupid. Don't do that. Anyway, is that cool?
Yeah,
all
I got
right.
it now.
Now the other level of this, that's like the roots that work. What about the roots that don't quite work? And what do I mean by that? Like square root of 18. Holy crap. If it was the square root of 16, I could do that. What's the next number from 16 that I could do the square root of? I could do square root of 16, I could do square root of... What's the next number? So I can do square root of 9, right? What's square root of 9? 3. Square root of 4 I can do, right? Yeah, 4. Square root of 4. Square root of 16 is 4. What's the next one I can do? Square root of 25, because that's 5. 5 squared is 25. So can I do the square root of 18? No, it's in between those two that I can do. Right? So on one level you guys are like, well then why did you give me this problem? You just said I can't do it. You can't do it exactly. Sort of like, can you divide 6 by 3? Totally. Can you divide 7 by 3? No, but can't you still do something with it? Can't you rearrange it? Alright. So here, what I can do is split that up. It's into a product of two things. Part of it I can do, and the rest of it has to stay. Right? So how can I break 18 up? Yeah, 9 and 2. Isn't that 18? And what is the square root of 9? 3. And what is the square root of 2? I don't freaking know. Now this is where I showed you an alternate method that will always work also, but thankfully not a lot of people, but a few of you guys made the mistake that I pointed out will happen with this method. If you just break this all, you see 6 times 3, and then you say, okay, that's 2 times 3. What are you looking for if you do this method? Yeah, it's a square root, so I'm looking for groups of 2, right? So what is our group of 2 of?
3s.
2 3s. So what goes where then?
3 on the outside.
3 on the outside, because the answer to a square root is the things that there are 2 of. So 3 on the outside, and there weren't enough 2s for them to escape. So some of you guys had that reversed, because you're guessing. There's no need to guess. It takes 2 of something for it to escape. There's only 1 of that guy who didn't escape.
If there had been 2 2s and then 1 of another number, would you take both of the 2s and divide by 2? 3 times 2 for the outside?
Oh yeah, sure.
Multiply it.
So like this here, let me do this here. Like square root of 36. If you start to break that up, let me make it even better. Square root of 72. So break that up for me. Start to break that up. 8 times 9, I like it. Can we do 8 straight up into all its parts? What's 8? 2, 2, 2. Good, so we should know that. 9 is? Alright, now, this is why I prefer the other method a little better, because it feels less like you're guessing what to do with shit, right? But if this method makes more sense, just be careful about what you do with it. So what's allowed to come out front? Well, let me ask you this. What's going to stay inside? 1 of these 2s, because there's 3 2s. Oh shit. So 1 of these 2s is going to stay. Now, what can come out? Yeah, a 2 times a 3. Why times? Because everything is multiplying. They're all multiplying. So why would the operation suddenly change? So if I could bring a 2 out, and I could bring something else out, I multiply it by what I already brought out. I like it. And then, of course, what do you get? 6 rad 2. Now, the other way to do that problem, the way that I prefer, just because there's less guessing to it, but if you do it this way, you're fine. I'm not going to go, I'm giving you less point. No, screw that. Get it right, you're fine. But this is why I prefer this way. I can break this up as square root of 36 times square root of 2. What is the square root of 36? 6. What's the square root of 2? But it requires you to know squared numbers, so you know what to try to break it up into. But there's no guessing about what comes out. Do I multiply? No, you just do the root. Bam. Right? I'm trying to push you in that direction. But if you like this way, there's really nothing wrong with this way. You get your practice with your factoring and stuff. That's fine with me. Okay. I like it. I like it all. Yes?
I was a little confused with quiz 1B. It was 12 over 25 plus 3 over 20. I wasn't sure what you meant by the not LCD.
Did I take any points off?
You took 2 off.
Let's see. Probably wasn't. Oh, you just didn't read it. That's fine. So real quick, your question is more fundamental. Like, if I had 3/8 plus, what do you got, Jeff? You can do it. 7/4 or something. What would you tell this person that starts to do this? What would you tell this person? Okay, that needs a 4 and that needs an 8.
Just multiply 4 by 2.
So that's my point with you. You used too much. You made the numbers bigger than they had to be. So now let me come back to reminding everybody a really cool method to use for fractions that have gross denominators, or fractions. It's not their fault, man. I'm not gross. I was just thinking. So, for example, if I had, what you got, Jeff? Jeff, I got, 8 over 21 plus 3 over, 28. I like it. Nice and gross. So you could start listing multiples of one of them and seeing when they overlap the, oh my God, dude. Oh my God, I don't want to do that crap. Now, if you want to do that, it'll work. But what's the method I use? Let me remember. Give you a little hint. What number goes into both? What's the biggest number that goes into both? 7. So that's 7 times what? 3. And that's 7 times 4. Now you can focus on, it's sort of like you see what they already both have. They already both have a 7. Why would I give them another 7? They both have a 7. What's the only thing this guy needs? A 4. What's the only thing this guy needs? 3. So now they both have the same bottom. So up here I get, what do I get up here? 32 over, what's 21 times 4? 84. Plus 9 over 84. So I didn't have to give this guy 28, and I didn't have to give this guy 21. They already had something in common. I can give them both something lower. I don't have to make my number so huge.
I have no idea. Bless you. I'm kind of suffering from a brain fart right now, and I can't remember what 29. No, not 29. See, that's how big of a brain fart I have. 25 and 20 go into.
Oh, well, what goes into both 25 and 20? What's the biggest number that goes into both of them?
4.
Well, into 25.
No, I'm thinking something else. 5.
5. There you go. So then you break 25 up as 5 times something. You break 20 up as 5 times something. And then you can see what they're each missing.
Okay, so
compared to each other.
25 is 5 times 5, 25
Good.
times 4. So
No.
5 times 5 times 4, and 5 times 4
Yes,
times
cool.
5.
All right. I don't want to do that problem because that's unfair to the people that have the other versions of the quiz. Cool. I like it. Oh, did anybody not get their quiz back? Oh. Who are you people?
No, I haven't.
Jonas. Who else is that ready? Oh. What's your name? Oh, man. Yeah, so you need it. You missed this quiz. Here's a copy of it. Just so you see what it looked like.
That's freaked out with a C. I'm just glad I get a C.
Are we gonna do this statistics?
Sure. Yeah, guys. Just to remind you, everything I've done so far is based off of questions you give me. I came with nothing. I have the answer key for this, but as far as plans for today, nothing. It just depends on what you ask. I don't know who's first. Okay.
Section 1.7, number 117.
Oh, okay. This one, I don't want to spend a lot of time on this because I'm not even going to have this on the test. The minute I say that, you're all like, screw that part. But here, it's really just an exercise in plugging in the numbers correctly. So I think I went over why this is true. The sum of an arithmetic sequence. And I told you the urban legend of math, and if you missed out on that, too bad. You can wait for the movie. So that's for an arithmetic sequence, and then for a geometric sequence, it's got the R showing up like that. So it's really just plug and chug for these. It's really just identify what the formulas need, and then plug those values in. That's what those problems are. So for number, what was it? Which one? 117. Or are we looking at number 17? Or 117?
117.
Thank God, okay. So 117 is this sequence here, right? 2, 6, 12. Is that the one? And 2, 6, 18, and 54. Alright, so what kind of sequence is it? Arithmetic or geometric? Geometric, because I keep doing what? Multiply by 3. So I know I'm going to use this guy, because R is 3. What else does this formula need? A1 is what? 2. A1 just means the first number. That's why it's A1. And it wants to figure out the sum of the first 10 terms. So N is going to be 10. So it's really just plug and chug. Put a 2 here, put a 3 here and here, and put a 10 there. And then just slap that bad boy in your calculator.
Do you subtract the 1 minus R first and then do
You tell me. Please excuse my dumb ass son. Right? Or dear Aunt Sally, if you like a less offensive one. So do you subtract or do you do exponents first?
exponents?
Exponents. Total.
Okay.
So for example, if I had 2 times 7 to the 5th power, that is not 14 to the 5th power. Hell no. How many 2's do I have? 1. How do I make 5 14s if I have 5 7's and 1 2? I can't do that. So order operation saves you from even having to think about it like that. Do the power first and then multiply. Order operations. Okay, cool. No? What's up?
No, I was just saying, when you start doing things, I think sometimes you forget about you forget almost forget about the order operation. You just figure out
What I'm trying to say is, just to remind you guys, there's no section that this only lives in. This lives in all of math. I mean, don't say, well, we left the order operations section. It's always, it's the grammar of math. Anywhere you use math, you better use the right grammar. Or else I ain't gonna know what you're talking about. How's Big Me go now? What? Use the right grammar? I know I don't always use the right English grammar, but I use the right math grammar all the time. Because math is my first language. Yes, ma'am. Oh, did I skip somebody? Did you? Let me go here and then you.
Okay, thank you. Can you do letter D from the practice quiz that you gave me?
Oh, is this your copy of quiz 1?
2, sorry.
Quiz 2?
Yes.
And that was like the
Subtracting rows.
Okay, gotcha.
Yeah, I just want to double check it,
All right. So let me build up to that. Can you guys help me out? What would this be here? I know it's not your problem yet because this is easier than your problem.
5 radical.
Is that cool? You guys understand that?
Right.
7 of anything minus 2 of that same thing is 5 of those freaking things. I don't care if you're talking about math or you're talking about chairs.
I had 7 chairs. You took 2. What do I
You got 5 chairs, man. So I got 7 of these minus 2 of these is 5 of these. I mean, that's not even mathematical. That's just keeping track of things, right? That's all that is. So if the question then is actually this, 4 square root of 18 minus, what do you got, Jeff? 3 square root of, you can do it, 8. I have to encourage myself. Hopefully, I got to think ahead and make it actually work. So, all right. No.
2 times 9. 2 times, like, you break down.
Yes, good. So 18 is 9 times 2, so that's all multiplying, right? 4 times that times that.
So 12.
Is that cool? Anywhere I see 18, I can replace it with 9 times 2. Anywhere, anytime I want to. Here it actually makes sense. Why don't I use 6 and 3? Because neither one of them go along with the square root. I use a number that actually works with the square root. So over here with 8, 4 times 2 is 8. I like it. And of course, if you like the other method where you just break the number down, cool. You can do it that way too. So what is the square root of 9?
3.
See how I just rewrote everything? So what's that going to be on the next step? 12. Whatever's already out there gets multiplied by whatever you bring out, because what's the operation? Multiplication is sitting next to it, right? The operation, you can't suddenly go, I don't want to be multiplication. Minus 3 times what? 2, which is 6. I got 12 rat 2s minus 6 rat 2s. So why couldn't I just say, I get this as the answer? Where do you think I got, who gives me that as the answer? What are they thinking? Yeah, 4 minus 3 is 1. 18 minus 8 is 10. And they might be the same people that tell me 2/5 plus 1/6 is 3/11. Right? It's the exact same mistake. Why can't I do this? Because these are not like terms. No good, please, God, don't write that down and say, my teacher said this. No. And why doesn't the same idea? These are not like terms. How the hell can you combine them? How can you consolidate them if they're not like? This is, I got, and now 12 of these minus 6 of these is 6 of those. Bam. Please understand, if I let you use a calculator and this problem is on there, don't be giving me a decimal answer. No.
That's what it told me.
No. I need you to do the work. Calculators, for the most part, for us will be to check work and not to do the work, or else they go on to the next level. You take the class. Your calculator's like all graduating. Yes.
For the one that's on the practice quiz, is it possible for the answer to be 0?
Totally.
6
Sure.
radical 5 minus 6 radical 5. That's what I got.
It's 0. Exactly.
So
some
the answer.
people,
That's why I was like, I don't know.
some people had something left alive at the end, but if I have 3 rad 11 minus 3 rad 11, that's 0.
Okay.
I took it all away from itself, the poor dude. Now there's nothing left. You guys are like nice. You're like, I want to survive. Or no, they're all dead. 0. They all die. 0. Okay.
I have a question from practice test 1.
Sure.
G and 6.
6G. No. 1G, and then number 6. Okay. All right. What's up here? How many of you guys have tried this problem out, or anybody try the practice test out yet? Even if you say no, it's okay, because you should be focused on homework primarily. So if you don't even do this ever, I don't need you to. I'm going to give you the answer key, so, you know. But this is just for practice. So go ahead and do this problem, the rest of you guys, if you haven't done this yet. That is also yummy. I know you don't. You're like, I don't think you know what that word means. You keep using this word. I do not think it means what you think it means. Okay. Somebody got my reference? Inconceivable.
Never getting to learn more nature.
Yes. Yes.
Let's take my practice test to that paper, to that homework paper. I think that's mine right there.
No. Sorry, buddy. Do you need another copy?
Please.
Sure. You're just about to fall out. No, I don't want you to turn off. Stop it.
What's that?
I think I'm going to organize you guys into a strike force, and we're going to attack that room. Quiet them down once and for all. They're watching you, yes. It's not actually happening. It's so dramatic. Arguing in French. Right.
Hey, my croissant.
My croissant. It's my croissant.